Presentation of D4K on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
Electricity powers just about everything in our lives, but where does it come from? And how does electricity work? We're standing by to answer your questions. Stay tuned. D4K is next. Hi, I'm Joan Cartan-Hansen. Welcome to D4K, the place for science. Before we go to your questions, let's learn a little bit more about electricity. When you turn on a lamp, electricity flows and turns it into light and heat. The electricity we use in our homes and schools starts at a power plant. Here in Idaho, a lot of electricity comes from hydroelectric power. These plants use water to turn a turbine in a generator. A generator is basically a big magnet surrounded by a coil of copper wire. As the magnet spins, it produces electricity. Now, electricity doesn't do you much good until it moves. Electricity flowing through wires is called an electric current. Electricity just won't flow through anything. Some materials conduct electricity better than others. Electricity can't go through plastic or rubber. Those things are known as insulators. Things like metal wires are called conductors. Once electricity is generated at the power plant, it flows to your home or school over wires. All the wires together are known as a grid. Power companies across the country work together to make sure the power grid is full and flowing. That way, when you turn on your TV, electricity powers it up. You can find electricity in other places. In 1752, Benjamin Franklin proved thunderclouds contain electricity. You know it as lightning. Static electricity is around all of us. It's caused by friction, like when you rub two surfaces together. Have you ever been shocked? Ow! That's static electricity. There's electricity in batteries. We even have electricity in our bodies. But don't forget, electricity can hurt you too. Don't get near down power lines, don't play with electric wires in your house, and stay inside when there's lightning. Electricity is a force to respect. And joining me now to answer your questions about electricity are John Gardner, Professor of Mechanical and Biomedical Engineering at Boise State University. He also leads the K's Energy Efficiency Research Institute. And Kip Sikes, Operation Analysis and Development Manager for Idaho Power. Thank you both for being here. Appreciate you joining us.
Thanks for having us. Thank you.
And joining us here in Studio A at Idaho Public Television are the students of Nadine Chafee's 3rd, 4th grade GATE class from Valley View Elementary. Thanks for being here. Okay, let's go to your questions.
Hi, my name is Joel, and my question is, what amount of electricity does the average U.S. person use in a week?
Well, Joel, the amount of electricity the average household uses is, just think of a horse. We think in terms of horsepower. So on average, a household uses 1.6 horses every second. So just think of that as a constant horse running around. That's about how much electricity you're using all the time.
Ryan asks, how do clouds get electricity?
So Ryan, I assume you're talking about lightning that comes from clouds, and this is a natural phenomenon that happens as the clouds move through the air. The atoms and molecules in the air and in the water in the clouds have free electrons, and they get exchanged as the clouds move through the atmosphere. And the electrons build up on the clouds, and they need, eventually after a little while, need a place to go. And they'll go to the closest spot that's of a different charge level, and that's usually why lightning will hit a tree or a tall hill. But it happens in the atmosphere as a course of everyday events.
My name is Megan, and my question is, how does electricity travel?
Well, Megan, the way electricity travels is really there's more than one way to make it travel. But normally what we think of traveling through a conductor or a wire is the electrons will bounce along and push each other along. But another way to make electricity travel is what we have in a lot of the technology that we use today. It's called a battery. So electricity can be stored and moved around and travel that way, but really for electricity to flow, you need a circuit, which means it has to be a complete connection circle all the way around to the source.
Hi, my name is Charlotte, and my question is, when was electricity discovered?
So we're not sure, I think, is the short answer to that question, but there was a lot of experiments, a lot of understanding of electricity that came about in Europe in the 1700s, and some of the scientists who did this work in their laboratories had the names that would now come along with electricity. So there was an Italian scientist named Volta, and we named volts after him. There's another French scientist named Ampere, who gives his name to current. So there was a lot of experiments being done, mostly with static electricity, with pieces of glass and various kinds of plastics and wool and cotton and things, trying to figure out how to make those little sparks that we now see when we rub our feet across the carpet. And that evolved over time. So it was over hundreds of years from there to creating a machine that, if you turned, could make electricity, and we call that a generator. And that happened through to probably the beginning of our electric grid, the modern electric grid, which was the late 1800s, with, of all people, Thomas Edison was the first one to create electricity, put it on a grid, and sell it to people in New York City.
Is that grid current in use today? Was it the one damaged so badly by the Superstorm Sandy?
Well, not exactly. No. So that actually opens a very interesting piece of our history of technology, because Edison created this grid using a generator that created direct current, or DC current. There were other scientists, other engineers who thought they had a better idea, and their name was George Westinghouse and Nikola Tesla, and they thought it would be better to use alternating current. And there was a big fight for decades, and they used public relations and a lot of pretty nasty tactics. If you think our politics today are bad, you should read about what those guys were doing. In the end, Westinghouse won, and we have an AC grid because of that, because the technology works better for that. Though there's some people now looking at DC again, thinking that there might be things that work better for that too.
Tyler asks, how does electricity end up in everybody's home?
Well, Tyler, the way electricity gets to your home is through a series of wires. It comes from a generator, obviously, and that has wires in it. And where it's produced, then it's moved through the system, in many cases, between states or throughout the region. And the grid, as it's called, the electrical grid, is a connection of all of these wires that moves electricity around the western United States. And those wires connect all the way to the communities that you live in, and then wires all the way to your house. So the really neat thing is it's all touching wires. If you could get really small and crawl into that outlet, you could go to anyone else's house that has electricity as well.
Hi, my name is Yoshinobu, and my question is, how fast can electricity travel through water?
So Yoshinobu, that's a great question, and the answer is, like a lot of things, it depends. So if it's pure water without any impurities in it, the electricity won't travel through it at all. It can't, because it acts as an insulator. But just small impurities, like we find normally in tap water or in water in our rivers, it will conduct electricity. And the more impurities in it, and particularly things like salt, are really good at conducting electricity, and it'll allow more and more electricity to move through it. But as we mentioned earlier, when electricity flows, it pretty much flows at the same speed, which is closer to the speed of light, which is very, very fast.
Owen asks, why is it when you rub your feet across the carpet, you make electricity?
Well, Owen, I think we've all done that and snuck up and shocked somebody. But the way that it works, again, is static electricity, is by rubbing your feet across the carpet, your shoes act as insulators, and as electrons build up on your body, you get one charge of electrons on your body that's different than somebody else. So the more you rub, those electrons transfer to you and can't get off of you until you reach to touch something. And that zap again, when you shock somebody, because you've built that up, that's actually a little mini lightning bolt, is why it hurts.
Hi, my name is Kendall, and I would like to ask, how does tidal power work?
Kendall, that's a great question. So tidal power is actually very similar to hydroelectric power that we're more familiar with out here in Idaho. So the water is held up by dams, and it gets higher and higher above the level of the river. And we use gravity to move that water down to the level of the river, and while it's on its way through, it spins a turbine that turns a generator. Tidal power can work the same way. In other words, sometimes the tides will rise and fill the water behind a dam. They'll close the dam off, and then it looks just like a hydro dam. Sometimes, if the tides are coming in through a smaller area, like a river, like outside of New York City, for example, the East River, they'll put propellers underwater, anchored to the floor of the river, and the tides will move past the propellers. They look like little wind turbines. They look just like the wind turbines we see out there, just smaller. And then the flowing water moves the propellers or the turbines, and that turns a generator. So both of those methods are being used.
Ryan asks, what creates the electricity in solar panels and lightning?
Well, Ryan, the way electricity is created in solar panels is solar panels are basically just sand or silicon. And as the sunlight hits them, the electrons in there get excited. But it's a little more complicated than that in that they have gates also that only let the electrons out in one direction, and that's what creates the current, is the electrons bounce out of the solar panels. Now, lightning is a little bit different in that it's actually static electricity. So just think of walking across the carpet and rubbing your shoes. Well, as clouds rub against the earth, or the atmosphere, if you will, charges can be built up that are different between the cloud and the earth. And once that gets strong enough, there's enough difference in the electrons and the positive and negative charges that it will, what we call, ionize the air. That's that big zap that allows the electrons to go through the air down to the ground to balance out the charges again.
Hi, my name is Claire. My question is, how much electricity can tidal power produce?
So Claire, that's a great question. And there's lots of areas in renewable energy that we don't know much about yet, and tidal power is one of them. So the moon's orbit changes the level of the oceans twice a day throughout all the coastal areas of the world. And if the conditions are right, where we have high tides and the right kinds of harbors or inlets, we can build devices that can harness that energy. The answer to your question is not very much. We don't do very much of that right now throughout the country or throughout the world, but it's an exciting area of research, and a lot of hope to do that in the future.
If you traveled as fast as electricity, you could go around the world 8 times in the time it takes to turn on a light switch.
Hello, my name is Moses, and my question is, what properties of metal and bone make them such great conductors of electricity?
Well, Moses, what makes a good conductor is something called free electrons. In other words, it's made up of atoms that have a lot of electrons that can move from atom to atom without a lot of resistance, so that they can move easily. But just like a piece of metal or your bone, it doesn't mean electrons are moving through there constantly right now. It takes a difference in voltage to make them move. So if you can push the electrons and they'll move easily, that's what makes a good conductor. Something that's an insulator is where the electrons are bound very tight together and don't move. So even if you push on the electrons, they're going to stay in place.
Elizabeth asks, why do they need acid in batteries?
Well, Elizabeth, the reason that you have acid in batteries, or what are called lead acid batteries, are the acid creates a fluid that allows electrons to be stored in it. It's actually an isotope. So the acid, when it interacts, the electrons can move freely through the fluid, but just like the impurities in the water, if you didn't have this acid in there, there wouldn't be enough electrons or ions to exchange with the metal plates in the battery. So the acid really is a way to store electrons until you complete the circuit and allow the electrons to flow.
Molly asks, how does electricity travel through wires?
Well, Molly, the way electricity travels through wires is much like water goes through a garden hose, if you've ever experienced that, is the electrons are really the electricity that's moving through the wires, and they bump along from atom to atom in a conductor. The electrons are free to move. So they push each other along just like water goes through a garden hose.
My name is Cannon, and my question is, why are there so many different electrons in just a 1 by 1 inch piece of magnet?
That's a great question, and it actually it's hard to understand because electrons are very, very small, and they're in everything that's around us. Every matter, everything that's made up of stuff, is made up of atoms, and atoms have 3 kinds of things in it: protons, neutrons, and electrons, and a lot of electrons. And so, if I understand your question right, why are there so many? It's because they're so small. They're smaller than anybody can see, and even smaller than our best microscopes can see. So it's a little hard to get your head around that, but it's a huge number of electrons.
Xander would like to know, what is the difference between static and regular electricity?
Well, Xander, static electricity is kind of what static means, is it's not moving. So it's just a difference in what we call potential, or which is voltage. So static electricity doesn't have any current, or no electrons are moving. So normal electricity is when the electrons are moving, and it's the moving of those electrons that does work or is usable. So static electricity is kind of like a battery. It's there, it's ready, but it's not doing anything at the moment.
Hi, my name is Clay, and my question is, how long until the world runs out of fossil fuel to burn to make electricity?
Clay, that's a great question, and you're not the only one asking that question. That's a question that we're asking ourselves, and world leaders around, all around the world are asking all the time. And unfortunately, the answer is we don't really know, because the fossil fuels are buried deep under the crust. We know where we have found them in the past. We know where they're easy to get, but we're constantly finding more. But I think the most important answer to that question is that they will eventually run out, and finding out what to do to make the electricity to power our society once that runs out is probably the most important question of what is likely to be your generation. And I think keeping asking that question is the best thing we can do.
Aubrey's question is, why shouldn't you put rugs over power cords?
Well, Aubrey, this is a very important question because it's really about safety. If you put rugs over power cords and walk on them, just walking on them can bend them and either break the wires or possibly damage the insulation that is around the wire that keeps the electricity in the wire. So that could start a fire if the electricity could get out, or in the best case, if you break the wire by walking on it, then the cord won't work anymore.
From Cameron, is it possible to have too much electricity when you charge an electronic device?
Well, Cameron, having too much electricity can be as bad or even worse than not having enough. So when you're charging an electronic device, the reason that you're charging it is the device's voltage is lower than it needs to be, and it doesn't have enough electrons stored in it. So as you're charging it, you're moving electrons into it. But as you do that, the voltage in the device comes up, so it will start to counterbalance, and then the electrons will quit moving back and forth. And so that's when it's charged. Now the important thing here, though, is to plug it into the right voltage. If I plug in something that requires 12 volts, like a car, to something that's supplying 100 volts, that's going to be too much electricity to charge the device.
Caden asks, how does a battery store electricity?
So, Caden, a battery stores electricity through a certain kind of chemical reaction, and different batteries have different kind of chemistry in it. But there's 2 different chemicals that when they react together, when they're put in close contact, will push electrons away and make them available to turn on your flashlight or to run your cell phone. The same thing happens in reverse. If you put electricity into a battery, it reverses that chemical reaction and turns it back into those other two chemicals. And so it's a great way to store energy, and they're storing it in a way of chemistry as opposed to electricity.
Abby would like to know, when you put jumper cables on a car, can the car run again? How does that work?
So Abby, that happens. The reason you use jumper cables is because the battery that's in your car that you use to start the car has died or has run down. Maybe you left the lights on, or maybe it got cold out and the chemistry got affected, or the battery's just old. So to get the car started, you need that electricity that's stored in the battery to turn the starter motor that turns the engine and gets it going. So when the battery's dead, you can't turn the starter motor. So jumper cables let you hook up your battery to somebody else's battery. You're essentially using the other battery to start your car and to recharge your battery a little bit. But once your car's started, it's got a generator inside that'll recharge the battery. And if all you did was leave the lights on, then the battery will recharge and you'll be fine, and it should work again for a while. But if the reason you had to use the jumper cables is because your battery was old, you probably will have the same problem again next week or tomorrow, and so you need a new battery.
Hello, my name is Owen, and my question is, what is the most efficient electricity generator?
Well, Owen, there are lots of different ways to think of what's the most efficient electricity generator, because the generator itself is just a way to convert one form of energy into electricity. So you can converting wind into electricity is taking physical force from the wind and turning something that then generates electricity, whereas the falling water, burning fossil fuels is another conversion. So when I use heat to create steam to turn something, that's much less efficient than just turning it with other mechanical forces. So the efficiency, as we try to measure it, is the total energy in versus the amount of electricity out. And the most efficient one then is that loses the least amount of energy converting it to electricity.
Braden asks, if you get shocked, what happens to your brain?
So, Brighton, that's a great question, and of course the important thing is to not get shocked, because electricity can be very dangerous. And it depends whether the electricity actually travels through your brain or not. Usually most people who get shocked, it travels through your arms or your legs, and it can disrupt the way your heart beats, or it could actually cause burns on your fingers or other places where the electricity enters and leaves your body. But yeah, your brain has a lot of electrical activity in it. That's how it makes it kind of work and helps you think. And so it certainly can scramble that a lot. And even a small amount can make you unconscious or cause a lot of pain.
Hi, my name is Iris, and my question is, does hail affect power lines when it's hailing?
Well, Iris, the way hail can affect or anything falling out of the sky, whether it's frozen water in terms of ice or hail, or even the wind that might come with the storm, is the power lines are suspended on towers. And if enough things hit them with enough force, they could be damaged or broken, or the insulators could be. So if a power line falls on the ground, you want to stay away from it because you don't know if it still has electricity or not. But that's one way that storms or the weather can knock down a power line.
Mackenzie asks, can we ever run out of electricity?
Another great question. And I think the better way to answer that is to think about where electricity comes from. So there will be things that we make electricity from, like solar energy or wind or hydro, that is by definition renewable, right? It keeps coming back, and so we get snowpack in our mountains that fill our reservoirs every year, and that'll be available to make electricity next year and the year after that and the year after that. As long as we've got water on the planet and it rains, we'll be able to make hydroelectricity. As long as the sun shines, we'll be able to make electricity from the sun. What we will run out of are the fossil fuels that we depend on for about half of the electricity, or two-thirds of the electricity that we use in this country. And I think that's something that we need to be addressing, and we are. We're doing a lot of research in how to make the renewable energies more reliable and less expensive.
Why did you both decide that you wanted to get a job dealing with electricity? What was it that made you want to do this for a living? John, why don't we ask you?
Well, I'm a professor of mechanical engineering, and so that's not something you often associate with electricity, but I'm very interested in energy and how society uses it and how we use it as a society. So when you start going down that road, you immediately get to electricity because that's predominant. That's the most valuable, the most flexible use of energy we have. So over the last 10 years or so of my career, I've spent a lot of time working in the area of electricity.
And Kip?
Well, for me, getting into electricity was kind of a no-brainer in that my father worked for the electric utility as well. But what really interested me in electricity is math. Because I love math so much, electricity you can't see. So the way we understand electricity is through using math and equations, and that allows us to then simulate or run computer models or think about how it works and just discover how to use math for something that no one can see. And besides, if you can't see it, no one can prove you were wrong, can they?
And then the follow-up to that is always, if someone wants to do this for a living, what should they study in school?
Well, definitely to get involved in any engineering field, but in electricity or energy, understanding math is very, very important, but also the sciences. Now, it's also important to recognize it's not just physical sciences that would be physics and chemistry. Those are very, very important. But electricity is also very used and useful in biomedical as well as biology because our bodies run on electricity as well. So understanding electricity is part of understanding yourself.
Yeah, that's absolutely right. And I think it's also important not just to be able to participate in your math courses and do well in math, but also to be curious. And the kind of questions we've talked about today are exactly the right kind of questions. If you're wondering about how electricity works, keep asking those questions and look for those answers.
I'm sorry, we've run out of time. Thank you very much. Thanks to John and Kip for joining us this evening. And also thanks to Nadine Chafee's class for providing us with the questions today. You can learn a lot more about electricity and all of the other scientific topics on the D4K website. We'll answer more questions about electricity on our D4K web only. And each week, check out my science blog for the latest science news for kids, all at idahoptv.org/D4K. Thanks for joining us. We'll see you next time on D4K. Hey, do you have a science question?
Yeah!
Do you want to win some prizes?
Yeah!
When you send us a question to use on D4K, you and your class are eligible to win DVDs and other prizes. Last month's prize winner was Lena from Mrs. McCamish Cameron's class at Grace Jordan Elementary. If you want to submit a question, check out the D4K website for this season's topics and send it in. You can send it as an email or as a video question. Record it on your webcam or cell phone. And if you're an educator, we'll even lend you a camera. Find out all the details on how to send in your questions and how to win on the D4K website. That's idahoptv.org/D4K. D4K, the place for science.
Presentation of D4K on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
If you want to learn more about this topic or watch our videos, check out the D4K website at idahoptv.org/D4K.